If reality seems logical to you, you likely haven't examined it with enough scrutiny. Among the most bizarre concepts in science and philosophy, many only emerge because reason stumbles over its own complications, ranging from loops involving time travel to holes that stretch to infinity, and the notion that you might truly be immortal. In this video, we'll explore all those mind-bending puzzles that continue to elude us regardless of our efforts. And these are 25 paradoxes that uncover the peculiar essence of reality. But before we dive in, two things. 1. Do me a favor. Hit like, and if you are watching this video, please subscribe our channel, Epoch Docs, and tap that bell, because you're going to need to find your way back. And 2, my voice is still completely shot from the Tampa Bay Buccaneers game the other day, so hasn't come back yet. I apologize. Bear with me. With that being said, let's go get paradoxy. It's not a word, I just made it up. 25. Can time travel erase your own existence? The grandfather paradox is what happens when cause and effect stop getting along. It goes like this. You travel to the past and do something that prevents your grandparents from ever having kids. That means your parent never exists, neither do you, which raises a problem because you're the one who caused it. Still, if you never made the trip, then your grandfather lives. Your parents are born, and you get the chance to do it all over again. Some scientists argue that reality would stop you before that point, like the universe correcting itself. Others think you'd just split off into a new timeline where you never appear at all. Either way, that's why every time travel plot eventually collapses. The moment you try to rewrite history, logic gives up. 24. Who wrote Shakespeare's plays? Stick with me for a second. Picture someone obsessed with Shakespeare. They jump back a few centuries, hand him a printed copy of his own plays, and walk away before he's written a word. Shakespeare copies them down, releases them, and history carries on just as we know it. Who actually came up with those plays? The traveler only knew them because Shakespeare wrote them. Shakespeare only knew them because the traveler handed them over. That's what people call the bootstrap paradox. It's a loop where something exists purely because it already existed. Sci-fi writers love it. We'll see it when a character passes an invention or song to their past self, keeping the cycle alive forever. It scrambles the idea of cause and effect because the thing never really began anywhere. It just keeps circling through time. 23. Are your friends actually more popular than you? If it ever feels like everyone on your feed has a busier social life than you do, science says you're probably right. It's called the friendship paradox, and it shows that most people's friends tend to be more popular than they are. It sounds strange. I mean, you'd think the math would balance out, but it doesn't work that way. People who are naturally outgoing show up on lots of friends lists, so they get counted again and again. Someone's connected to, let's say, 100 people, and another has just a couple. Odds are you'll bump into the one with the 100. When researchers at the Santa Fe Institute crunched the numbers, they found something extra. The bigger the popularity gap, the stronger the effect. The same pattern shows up with money, looks, and social connections too. It doesn't mean you're doing badly. It just means that our view of the world is tilted towards the people who stand out the most. 22. Are you dreaming right now? The Taoist philosopher named Zhuangzi once dreamed that he was a butterfly fluttering through the air without a care in the world. When he woke up, he could untell if he was a man who had dreamed he was a butterfly, or a butterfly now dreaming if he was a man. I know it sounds like nothing more than a silly story, but it raises a serious paradox of reality. The difficulty of distinguishing reality from illusion? It's one of the earliest records of the question, how do we know our reality is real? If your experiences as a butterfly were indistinguishable from waking life, who's to say which is the true reality? Everything we see, touch, and hear could be part of the same illusion. Zhuangzi's point wasn't that he literally thought he was a butterfly, but to shake our confidence in what we call real. It also reflects a Taoist perspective that life's distinctions like self versus other, man versus butterfly, are not as fixed as we think. It leaves us with a wonderful uncertainty. Maybe life is nothing more than a dream and the real awakening is yet to come. 21. Do black holes make things disappear forever? Stephen Hawking once suggested that black holes slowly fade away and that everything that falls into them is lost forever. That idea didn't sit well with other physicists because quantum mechanics says information can change or scatter, but it always has to exist somewhere. The stalemate became known as the black hole information paradox. Now, I have to mention that we know more today than Hawking did at the time. According to his math, black holes emitted radiation with no sign of what fell inside. But some of the latest research points to a different story. Scientists now believe that once a black hole evaporates, faint bits of information seem to seep back out through that radiation, scrambled beyond recognition, but still there. Over time, enough leaks out to suggest the information isn't truly gone. So, while you won't be rescuing anything that falls in, the universe might be better at keeping records than Hawking first thought. 20. Can time move at two different speeds? Einstein's theory of special relativity says time doesn't flow the same for everyone. The faster you move, the slower time passes for you compared to someone standing still. The twin paradox is the thought experiment that shows just how strange that can get. One stays on Earth while the other, let's call him Bob, takes a high-speed trip across the galaxy. From Bob's point of view, time feels totally normal. He eats, sleeps, and ages like usual. But when he comes back home, he finds that his twin on Earth has aged far more than he has. For him, a few years might have passed, while for his twin, it could be decades. The paradox comes from the fact that both perspectives seem valid. Each twin thinks the other is moving. The solution lies in the turnaround because Bob had to accelerate and decelerate to come home, which breaks the symmetry. That's why his clock ran slower and why relativity still wins. 19. Does a red apple prove that all ravens are black? Let's start with the simple claim. All ravens are black, fair enough, right? Okay, let's take it a step further. If you're a logician, you reverse that and say if something isn't black, then it isn't a raven. So weirdly enough, spotting a red apple technically supports that claim that all ravens are black. That idea is called the paradox of the ravens, and it highlights how formal logic doesn't always match common sense. It's technically correct, but useless in practice because no one tests bird color by looking at fruit. 18. When does a pile of sand stop being a pile? Start with a pile of sand. Take away one grain and it's still a pile. Take away another, and another, until you're down to one grain. Nobody would call that a pile. But where exactly did it stop being one? The Surretta's paradox calls out a flaw in how we think. We treat gradual change as if it happens in neat steps. Each tiny change seems meaningless, but enough of them can completely flip the outcome. The same logic applies to things like baldness, height, or wealth. When does a few hairs make someone not bald? When does 1 inch make someone tall? The paradox shows how tricky it is to draw clear lines in a world full of gradual change. We like neat categories, but real life doesn't always work that way. 17. How do you fit infinite guests into a full hotel? Hilbert's Grand Hotel is an imaginary place with endless rooms. 1, 2, 3, 4 going on forever. In this scenario, every single one is taken, and somehow, the manager can still welcome new guests. How? By asking everyone to move down one room. So, for a quick and easy visual, what he does is simply makes everyone shift up a room. That first guest takes the next one. That person moves to another, and the pattern continues forever. Just like that, the very first room is open again. But then an infinite line of new visitors arrives, no problem. The manager now tells each guest to move to a room that's double their correct number. The person in room 3, for instance, slides in room 6, freeing up every odd-numbered space for the newcomers. Hilbert's paradox shows that in a world with infinity, even no vacancy doesn't mean much. 16. Can Achilles ever catch the tortoise? Zeno AA came up with a paradox starring Achilles, the fastest man around, and a slow-moving tortoise. To even the odds, the tortoise gets a little head start. Achilles springs to the spot where it began, but the tortoise is already inched forward. He runs to that new point, and it's moved again. No matter how small that gap gets, there's always another one left to cross. If you keep dividing the distance forever, it looks like Achilles can't ever overtake the tortoise. Centuries later, however, mathematicians settled it with calculus and proved that even an infinite number of tiny steps can still cover a real finite stretch of ground. Achilles ultimately wins, but our math had to catch up to prove it. 15. When does something stop being itself? The Greek writer Plutarch once asked a question that still messes with people's heads today. If you replace every plank of a ship one by one until none of the original pieces remain, is it still the same ship? If you ask sailors, they'll say yes, it's the same ship they've been fixing and sailing for years. But what if someone saved all the old planks and rebuilt the original ship from them? Now there are two versions of the ship, both claiming to be the real one. So which one is it? The one that kept sailing, or the one made from the original parts? Philosophers have argued about the ship of Theseus paradox for centuries, using it to explore what identity really means. Are we defined by our materials or continuity or something else entirely? After all, even humans replace almost every cell in our bodies over time, and yet we still call ourselves the same person. 14. How can the same data tell two opposite stories? Have you ever seen stats that completely change meaning when you zoom out? That's Simpson's paradox. It's when a trend shows up inside separate groups but reverses or disappears once you combine them. On paper, women were being accepted at lower rates than men. But when researchers broke it down by department, the numbers actually showed the opposite. The women were doing slightly better. See, the women had been applying to the tougher departments with lower acceptance rates overall, while the men applied more often to the easier ones. So, each department told one story, but the total told another. 13. Can an all-powerful being limit its own power? If absolute power means being able to do anything, then there's a problem that shouldn't exist but does. Can an all-powerful being make a stone so heavy that even they can't lift it? Any answer traps you? Say yes, and there's something they can't do. Say no, and that's still a limit. Either way, the definition of all-powerful begins to fall apart. The omnipotence paradox shows how logic breaks under its own weight. Some philosophers will argue that it's a trick question because real power would uninclude things that are logically impossible. Others think it exposes the boundary between reason and imagination. Whatever side you take, it forces one conclusion. Maybe true power isn't about breaking logic, but knowing where it stops. 12. Why is the night sky dark if the universe is full of stars? On paper, it sounds simple. If stars fill infinite space, then no matter where you look, your line of sight should eventually hit one. Even if distant stars look dimmer, there are enough of them to cover the whole sky in light. So why is it dark? That question is the heart of all's paradox. For the longest time, scientists thought it may have had something to do with dust clouds or uneven star distribution. But dust would heat up and glow too. And even if stars were spread unevenly, there are still billions of them. The real answer comes down to time and expansion. The universe isn't infinitely old, so light from the farthest stars hasn't reached us yet. And because the universe is expanding, much of that light gets stretched and reshifted until it's invisible. The darkness of night, ironically, proves we live in a finite, evolving cosmos. 11. Can you outsmart a crocodile? Crocodile snatches a child and gives the parent one shot to save them. Guess whether I'll eat your kid or let them go. If the parent guesses right, the child is freed. Guess wrong, and well, lunch is served. So what's the smart move? The parent says, "You'll let my child go?" There's no contradiction. The croc can either eat the child or let them go, and the rules stay intact. But if the parent says, "You'll eat my child," everything changes. If the croc then eats the kid, the parent guessed correctly, which means the croc should have released them. But if he releases them, then the parent was wrong, so the croc should eat them. The only real solution is to not play the crocodile's game. 10. Who shaves the barber? In a certain village, there is a barber who has a very strict rule. Shaves all and only those men in the village who do not shave themselves. At first glance, that's fine. He takes care of everyone who doesn't self-groom, but then asks, does the barber shave himself? If he does, then by definition, he shouldn't, since he only shaves those who do not shave themselves. If he doesn't, then according to the rule, he should shave himself because he falls into the category of men who don't shave themselves. It's a classic example of Russell's paradox discovered by philosopher Bertrand Russell in 1901. He realized that the same contradiction shows up in mathematics when we talk about sets or collections of things. If you make a set that includes all sets that don't include themselves, does it include itself? Say yes and it shouldn't. Say no and it must. 9. Can a little creature outsmart physics? James Clerk Maxwell had a strange idea in the 1860s. He pictured a tiny being standing at a door between two boxes of gas, quietly watching the molecules zip around. Whenever a fast one came by, it opened the door and let it through. Slow ones went the other way? After a while, one box was hot, the other cold, and no energy had been spent doing it. That's a problem because physics says you can't just make order out of chaos for free. The second law of thermodynamics insists that heat doesn't move from cold to hot on its own. So how did this imaginary creature pull it off? Well, it didn't. The being would still have to watch every molecule, store information, and eventually erase it. That process costs energy and increases disorder, which puts the balance right back to where nature wants it. 8. Are we choosing anything at all? If every event in the universe was set in motion by the Big Bang, then your decision to grab chocolate instead of vanilla was already locked in billions of years ago. That's the heart of the free will paradox. It's built on determinism, or the idea that every action has a cause, all the way back to the start of time. But modern physics and quantum mechanics say some events aren't caused at all. They just happen. So, which is it? Are our choices fixed or random? If everything's predetermined, there's no choice. If things are random, then choice is an illusion too. For all we know, life might just be running on autopilot, and we're merely along for the ride. 7. Can light be two things at once? Isaac Newton swore that light was made of particles, while Christian Huygens insisted it was a wave. Turns out both were right and wrong. Shine light through two slits and it ripples like a wave. Measure individual hits and it acts like a stream of tiny bullets. Even electrons pull the same stunt. Depending on how you set up your experiment, they'll behave like waves or like solid particles, but never both at once. Einstein helped to solve part of the mystery when he showed that light could knock electrons off metal plates, proving that it sometimes behaves like small energy packets called photons. Still, it refuses to fit in a single box. 6. What's the sound of one hand clapping? This ancient Zen riddle isn't really about sound at all. It's about perception. The question, what's the sound of one hand clapping, has no logical answer, and that's exactly the point. It's meant to short-circuit ordinary thinking and push the mind toward insight. Some say the sound is silence. Others, like the philosopher Serge King, argue that it is the same as two hands clapping because clapping is defined by the relationship between two surfaces, not the number of hands involved. Whichever the way you see it, the paradox points out that nothing means much on its own. A single hand, a single sound. I can't do it. Even a single thought needs something else besides it to take shape. Can you clap your eye? Know some people that can? Can you do it? Let me know in the comments. 5. Are we living in a world that isn't real? In Hindu and Buddhist philosophy, Maya refers to illusion, but not in the sense that the world doesn't exist. It means that what we see isn't the ultimate reality, only how it appears to us through perception and misunderstanding. The famous Sanskrit line, Brahman is real, the world is illusory, sums it up perfectly. The paradox is that we still live, strive, and suffer as if this illusion is completely real. Every pain, every joy, every success feels concrete. Yet in spiritual teaching, enlightenment means seeing through that illusion and recognizing the unity behind it all. Maya challenges one of our deepest assumptions, and that is that experience equals truth. It's a reminder that the version of reality we live in could just be the cover, not the book. 4. Is the cat alive, dead, or both? This is probably the most famous paradox on today's list. In 1935, Edwin Schrödinger dreamed up a very strange scenario. A cat trapped in a box with a radioactive atom and a poison vial. The atom's decay would trigger the poison, but no one could know the result until they looked. Now, according to quantum mechanics, that means the cat exists in two states at once. It's alive and dead until someone finally takes a look. Schrödinger wrote the setup as a joke, showing how silly it is to extend quantum principles to everyday life. But the idea stuck because it was too good. Experiment nailed one of physics' deepest problems: how observation turns probabilities into facts. 3. Can you change the past by watching it? What if your choice in the present could decide what happened in the past? Physicist John Wheeler based his question on an experiment with light. When light passes through to small openings, it can behave like ripples on water, spreading out and overlapping, or like tiny bullets hitting one spot at a time. What scientists found is that how you look at it determines which behavior shows up. Wheeler's variation was to wait until the light had already gone through before deciding how to measure it. Somehow the light's earlier behavior still lined up with that later choice. It's as if reality didn't settle on an outcome until someone checked. Wheeler even imagined doing it with light from galaxies billions of years away, raising a question that still bothers physicists today. Does an observation create the past? 2. Are you sure you're not just a thought? The Boltzmann brain idea starts with a strange question. What if you right now are nothing more than a brief accident of chance? According to this paradox, in an infinite universe, random fluctuations could eventually assemble something that thinks it's a person, complete with memories, surroundings, and even emotions included. The odds are obviously absurdly low, but infinity has time to spare. It's far easier for a single brain to pop into existence for a split second than for an entire universe to form the long way through stars, planets, and evolution. That means it's technically more likely that you're a lone, short-lived brain, imagining a life, than a real person living one. Do we ever really die, or just in this universe? Quantum immortality comes from the many worlds idea in physics that every possible outcome of an event happens somewhere. In one world, you trip and break your leg. In another, you miss the fall entirely. The theory gets strange when you apply it to life and death situations. If there are infinite versions of you, and in one of them you always survive, then from your own point of view, you'd never actually experience death. You just keep waking up in the branch where you lived. Does that mean we're immortal? Not necessarily. In most versions of you, you would still die. But it does make you wonder what consciousness really means. If your mind only ever experiences the worlds where it keeps going, maybe death is something that happens only to the versions you never get to feel. And on that interesting note, that's a wrap. Now time for a little brain teaser before you go. The friendship paradox says that your friends are more likely to have more friends than you. But according to network theory, what actually causes that imbalance? Is it A, highly connected people appear in more averages? B, algorithms amplify social hubs? C, introverts distort sample size? Or D, random chance across small networks? Drop your answer down below. And while you're at it, let me know what topic you'd like to see us unpack next. And if you've ever stayed up way too late wondering what's really going on out there, our related video, 25 Unanswered Questions About the Universe, should be your next stop. It's full of space mysteries that even NASA can't fully explain yet. That link will be appearing right here in just a few seconds. I guess there's a version of you that clicks that, and another one that doesn't, but be the one that does it. So thank you guys so much for watching. As I said before, like, share, comment, and if you're watching this video, please subscribe our channel, Epoch Docs, notification bell. I'll catch you guys next time. Love you all. See you.